In the world of data science, relying solely on the average can be a dangerous trap. While the mean tells us where the center of our data lies, it says nothing about its stability or risk. To truly understand a dataset, we must measure its dispersion, or how much the values fluctuate. Today, we will master the calculation of variance and standard deviation using Python's Pandas library to quantify what we call volatility. Our journey begins with data preparation. In a professional workflow, we first import the Pandas library using the alias PD. We then load our dataset, such as a CSV containing historical stock prices or sensor readings, using read.csv. Before calculating anything, we must isolate our target variable, for instance the price column, into a series. Pandas is designed to handle thousands of records efficiently, making it the industry standard for these operations. The first fundamental metric is variance. Mathematically, it is the average of the squared deviations from the mean. When we call the .var method in Pandas, the library subtracts the average from every single data point, squares the result to eliminate negative values, and then averages those squares. A high variance signals that the data points are widely scattered, indicating a high degree of uncertainty and volatility in the system. However, variance has a practical limitation. Its units are squared. If we are measuring prices in dollars, the variance is in dollars squared, which is difficult to interpret. This is why we use standard deviation, calculated with the .std method. By taking the square root of the variance, we bring the measure back to our original units. This allows us to say, for example, that a stock typically deviates by $5 from its average price, providing a clear window into its risk profile. Let's apply this to a real-world scenario, volatility. Imagine two different investments. Stock A and Stock B both have an average price of $100. However, Stock A has a low standard deviation, meaning its prices stay very close to the mean. It is stable. Stock B, on the other hand, has a high standard deviation, with prices swinging wildly between $80 and $120. In finance, this standard deviation is the definitive measure of market risk and volatility. One of the greatest advantages of Pandas is its intelligent defaults. By default, Pandas uses Bessel's correction, dividing by n-1 instead of just n, which provides a more accurate estimate for sample data. Furthermore, Pandas automatically detects and excludes missing values, or NaNs, from these calculations. This ensures that your risk models don't crash or produce skewed results due to incomplete data entries in your CSV files. In conclusion, mastering variance and standard deviation allows you to see beyond the average. These metrics are the foundation of modern portfolio theory, quality control, and predictive modeling. By using Pandas, you can transform raw, volatile data into clear, quantifiable insights for better decision-making. References: McKinney, WWW, 2022, Python for Data Analysis, Data Wrangling with Pandas, NumPy, and Jupyter, O'Reilly. Hull, J.C., 2021, Options, Futures, and Other Derivatives, Pearson Education. Gujarati, D.N., 2021, Essentials of Econometrics, McGraw-Hill.